So is my screen visible to all of you?
Yes, ma'am.
Okay, so good evening all of you. Today we are going to discuss about Introductory Organic Chemistry Part 2 NPTEL platform course. And the course instructors are Professor Harinath Chakrapani and Professor Neeraj Dashaputre from ISER Pune. And I am Simran, your PMRF teaching assistant. So till now we have talked about 6 lectures, right? So this is the seventh one. Okay. So I wrote week 6. Let it be. So today we are going to discuss about conjugate additions. Okay. So till now we have talked about enols, enolates, aldol reactions, and all sort of reactions like that. So today we will be talking about conjugate additions. So till now, in every week, you guys are going through my videos on my YouTube channel. So I'm just assuming it. So if you guys have any doubt regarding the previous lectures, previous sessions, any session, a week one, week two, respectively, so you can ask me now. So if you guys have any questions, any queries regarding the previous lecture,
Madam, this should be week 7,
yeah,
I
this is
think.
week 7 only. I just wrote it week 6 by mistake. It's week 7 only.
And another thing, week 6 is not uploaded in your YouTube channel.
Yeah, actually, I haven't uploaded the video. There was a bug in uploading that video when I was uploading it. So I will be uploading that video and this video combined today. Okay. So it will be
Okay.
available on that particular YouTube channel today only. Okay. Any other thing?
Madam,
Yeah.
can you speak uh, few something about protection, the protection of functional groups?
Protection and deprotection of functional groups. Actually, this is not incorporated into the course. So, this week we will be talking about conjugate addition, and next week is the rearrangements. So, deprotection and protection. I will check the module if that will be there. Then we will be shortly talking about it. Okay.
Okay, but our uh, faculty give some mention about this particular ketone and aldehydes.
Ketone and aldehyde. So,
Fine.
actually, I have incorporated that particular examples of protection of ketone and aldehyde na, in the last video.
Yes.
Yeah.
Yeah.
So that much only it was required. So I have covered those protecting groups by glycols, right? So
Yes.
so you have any doubt regarding that or what you are asking to me? So I'm not getting it. Do you have any query regarding that?
Actually, I have no query, but I want to lecture from you regarding protection and reproduction of functional group with respect to ketone, aldehyde, and alcohols.
Hmm. Yeah, I have talked about in the last lecture the protection of ketone and aldehydes. In that particular lecture, I have incorporated two or three examples for for the protection of the ketone and aldehydes. I hope you have seen that particular. Actually, I haven't uploaded the video now. That's why you are confusing with that. So I will be
Okay, ma'am.
uploading that video. Once you will go through it, you will get that I have talked about it. Okay.
Actually, I was absent week 6 live session.
Okay, you missed that. That's why you didn't know that. Okay, that's fine. I
Okay.
will be uploading that
Okay.
video. You can go through it. Okay.
Okay.
Okay, thank you. So any other thing? So if not, then I'm moving forward. So guys, this is week 7. I have mistakenly wrote it week 6. Let me correct it now only so that you will not get any confusions. Okay, so today, week 7, conjugate additions. We will be talking about this today. So, coming to problem number 1. So, in problem number 1, you have to identify the intermediate X and the final product Y in the given reaction sequence. So, this is the reaction sequence in which they have taken three conditions, and also you have to identify X and Y. So, one by one, we will go through it. So, in first condition, they have added LDA at minus 78 degrees centigrade. So, I have told you that at lower temperature, kinetic enolate will be the enolate which is going to be generated. So, can anyone tell me now from where the abstraction of proton will takes place? Here or here? So, basically, LDA is a base, it will abstract the acidic proton. So, will it abstract this HA proton or HB proton?
B proton.
B proton. Because here, after abstraction of this proton, there would be a generation of kinetic enolate, right? So I've talked about it that at higher temperature, thermodynamic enolate is the enolate which is in major product, and at low temperature, kinetic enolate is favored one. Okay, so here also kinetic enolate is getting generated, and how it is going to generate? So here you will be getting a double bond. Here there will be a negative charge, right? So like this will be a single bond now. So this is the inert which is getting generated. So now in the same pod, in the next step they have added methyl iodide. So now what will happen? This negative charge will attack on your carbon, and iodide will leave out as a leaving group. Because now here this is the nucleophile. So tell me, it has two options. One to react directly to the methyl, and the second one is to go through this position, that is the C2 position. Either way it can be done, this position or the oxygen directly attacking to methyl. So can anyone tell me which pathway is favorable, the pathway A in which the oxygen is directly attacking, or pathway B in which the carbon is attacking to the carbon? Which pathway do you think is favorable?
Pathway 2.
Pathway 2. Why? Because in this there could be generation of one OC bond in pathway A. So OC bond generation will takes place, right? And pathway B, CC bond formation will takes place. So as we know that the carbon-carbon bond formation is favorable, then carbon-oxygen bond formation, and also the negative charge which is getting generated on the oxygen ion will not be remain as it is. It will come down through the resonance, and then this C2 is going to attack. So the nucleophilic position is going to attack to the electrophile. So here what will happen? LDA first subtracts the proton from the alpha position of your ketone, and then it will attack to the methyl iodide. So then this methyl group is getting substituted here. So now X is sorted. So you got what it will be. Here there would be a methyl group which is connected at the C2 position in the X. So now after having X in hand, they have they have treated it with they have treated it with phenyl sulfide, basically this thiophenol. They have treated it with thiophenol and triethylamine. So thiophenol and triethylamine. Triethylamine is a base here, and thiophenol is a nucleophile here. So after the formation of X, this is X, guys. This would be X. So now tell me what will happen next. This sulfur has lone pair of electrons. So now at which point it will attack? It has two position to attack, either C4 or either C2. So which path it will choose to attack, C2 or C4? What do you think? The attack of sulfur, the attack of thiophenol, will it be taking at C4 position or C2 position of the alpha beta unsaturated ketone? What do you think?
Nucleophilic attack of metabolism.
Beta position. Okay. So it will attack to the beta position, that is the C4 attack. Why? Because I have told you previously that the nucleophiles which are having delocalization behaves as a soft nucleophile, right? So we have talked about it in the HSAB theory that hard nucleophile will attack to the hard position and soft nucleophile will attack to the soft electrophile, right? So here the beta position is a soft electrophilic position, and this C2 position, that is this, sorry, C1 position, that is the, this position is hard electrophilic position. So the nucleophile which is soft in nature will attack to the beta position which is soft electrophile. So according to HSAB theory, the nucleophile which has resonance stabilization is behaving as a soft nucleophile. So that is why here the attack will take place at the beta position, and what will happen? Now according to the resonance it will go like this. After coming back, there it will go like this. After this oxygen ion formation, it will go down, and again the negative charge which is getting generated here is trapped by the water which is present in the reaction. So here you will get this molecule generated, which is Y. Fine. So now tell me which is the correct option.
Last option.
Last option. So last option will be the correct one. So x is equal to this and y is equal to this. So is it clear to all of you how it is going to form? So if it is clear, then I'm moving towards the problem number 2. If anyone has any query, please ask it right now. Okay, if not, then I'm moving forward. So in problem number 2, you have to answer the major product formed in the following reaction is. So this is the reaction, and you have to identify the major product formed in the reaction. So they have treated this active methylene compound. We have talked about it also. What is an active methylene compound? So this is an active methylene compound. They have treated it with alpha beta unsaturated ester in presence of sodium methoxide and methanol. So sodium methoxide being a base, it will abstract a proton. So tell me, according to the previous knowledge, which proton is going to be abstracted? A or B? Because there is no other acidic proton which is present in the system, na? There is two acidic protons in the system. So just tell me which is going to be abstracted, A or B? We have studied in active methylene compounds that this position, this hydrogens are known as highly acidic hydrogens. Why? Because after the formation of negative charge at this position, it will present in the conjugation with both of the carbonyl compounds, right? But if the anion is getting generated at this position, it is only getting delocalized with this carbonyl compound of ketone. So that is why the acidity of these two protons, which is present at this methylene group, that is the active methylene site, it is higher.
Is not visible.
Screen is not visible. Is it visible now? So is it visible now? Yes, now
Yes.
visible. Okay. So I was saying that there is two acidic hydrogens that are present in the system, and I was telling you that I was asking you that which is the most acidic one, which is to be abstracted by this base, that is sodium methoxide. So can anyone tell me which is the proton which is abstractable by the sodium methoxide, Ha or Hb?
HB.
Yeah, Hb protons. Why? Because after the abstraction of Hb protons, the carbon ion which is getting generated at this position is in delocalization with both of this carbonyl compounds, and which is stabilizing this particular carbon ion. But the thing which is getting generated here, that is the carbon ion, is in conjugation with this carbonyl only of the ketone. So that is why additional stability is there for this active methylene compounds, that is this methylene group. So in the presence of base, abstraction of this proton will take place, and then it will be attacking onto this particular alpha beta unsaturated ester. Now tell me, the attack is beta, or the attack will be 1 2 or 1 4 in fashion?
1 4.
1 4. Why? Because here the nucleophile which you have generated is in conjugation, which makes it soft nucleophile. That is why it is attacking on this soft electrophilic center rather than the hard electrophilic center. Right. So here, this is how this carbon ion is attacking onto this position. Then this oxyanion will form, and after that, after the formation of oxyanion, this will come down, and this negative charge which is getting generated at this position will be taken up by this proton and get neutralized to give you this particular compound. So tell me which is the correct option. Option number. Sorry for the disturbance, guys. It is again getting like I don't know what is happening. Getting disconnected again and again. Okay. So I was here. Okay. So tell me which is the correct one. I have showed the mechanism, right? So what is the correct option?
Ma'am, screen it not visible.
Okay, screen is still not visible. I haven't shared, I think. Yeah. Sorry. Yeah. It's visible now, no?
Yes.
Okay. So this is how the attack is going to take place: the negative charge abstraction and then alpha beta unsaturated ketone attack, that is at 1,4 fashion. And after that, this oxygen ion will take up the proton from the system, that is from ethanol, to get you this compound. So the correct option will be option number D. Right? So is it clear? Okay, so if it is clear, then I am moving forward. So the problem number 3. So in problem number 3, you have answered that which of the following does not undergo a conjugate addition reaction with butanamine. So you have to identify which of these four compounds will not give you a conjugate addition, that is the 1,4 addition, when they react with butanamine. So basically butanamine is this molecule. So if you have this molecule in the system, then it is acting as a nucleophile. So nucleophilic attack will not be going to take place at as a 1,4 addition in which of the following compound. So what do you think? Which of these does not undergo a conjugate addition with this nucleophile? Any guesses? So if not, so one by one we will be talking about it. I hope it is not getting disconnected again. Okay, all of you are here only. Fine. So guys, for 1,4 addition, 1,4 attack to takes place, the necessary condition is the presence of alpha beta unsaturation in the system, right? So now tell me, which is not going to undergo a conjugate addition? Which of these species? Which of these four? I have given you a hint that alpha beta
Option
unsaturation.
C.
Yeah, because alpha beta unsaturation is important to get you conjugate addition. So in this case, option number A, the nucleophile can attack onto this position and can give you the conjugate addition. But in the option number C, there is an oxygen which is inserted between the alkene and the carbonyl compound. So the alpha beta unsaturation is now getting destroyed due to the presence of extra oxygen in between the alkene and carbonyl compound. So that is why it is not now a alpha beta unsaturated carbonyl compound. That is why it is not going to give you the conjugate addition. So rest of these three are present as alpha beta unsaturated ketones or aldehydes. Okay. So is it clear why the option number C is the correct one? Any doubts? Any queries?
No, ma'am.
Moving forward to problem number 4. So in problem number 4, you have to identify the product of following Robinson annulation. So this is they are saying that it is Robinson annulation. So now you have to predict the product. So they have treated this alpha beta unsaturated ketone with this 1,3 dione in presence of KOH, that is a base, ethanol as a solvent. So first of all, base will abstract the acidic proton. So from where it will abstract the acidic proton? HA or HB? Can you tell me which is the proton which is abstractable here by the base?
HB.
HB. Because after the formation of carbon ion at HB, it was in conjugation with this. Both carbonyl compound, a similar concept arises here also. But if the carbon ion is getting generated at HA, it is in conjugation with this particular carbonyl compound only. So one carbonyl conjugation is there, and after the formation of carbon ion, it is in conjugation with this both of the carbonyl compounds. So that is why the abstraction of HA proton will takes place, and the anion is getting generated at this position, irrespective of the presence of methyl group. So now again it will give you a 1,4 addition to this alpha beta unsaturated ketone. Why? Because it is in conjugation with this particular system, making it as a soft nucleophile. So this is the soft nucleophile. So if it is a soft nucleophile, then it has to be added to a soft electrophilic center. And we know that this is the soft electrophilic center, and this is this is hard electrophilic center. So now this will going to be attacked on this position. This will go here, and this will go here. That means our oxyanion is getting generated. So what will happen after that? This anion is getting generated. Now what it will do? Any guesses? Now this anion is getting generated. So what it will do? It will be attacking to one of the carbonyl of this particular nucleophile. So how it is going to be done? So in presence of base, this negative charge is getting generated. Alpha beta unsaturation is there. So 1,4 attack will takes place. And after the generation of oxyanion, that is this oxygen ion will come down, and this carbon will attack to your one of the ketone. So this will attack to one of the ketone, this particular carbon, to get you this compound. And after dehydration of this molecule, which can be done on this side, after the dehydration, it is going to give you alpha beta unsaturated ketone. So why the dehydration is happening from this side? Because of the generation of alpha beta unsaturated compound rather than a isolated double bond, which is to be generated here. So that double bond it's not in the conjugation with any of this carbonyl group, and that is why the dehydration from this position is facile rather than that position. So your dehydration,
Ma'am, how the excuse me, ma'am, how the cyclization takes place? Please, can you explain?
yeah, sure. So here the cyclization is happening like this. So basically you have this 1, 2, 3, 4, 5, and 6. Right? So this particular oxyanion will come down, and this negative charge will attack to this ketone, and it will go here. So there could be possibility that this will attack to this particular compound, this carbonyl group, or this carbonyl group, because it is a symmetrical molecule. So any of this carbonyl group can be attacked by this carbanion that is getting generated at this position to give you a 6-membered ring that is fused. So here I have shown the attacking at this carbonyl compound site. So this carbonyl group has attacked. So that is why you will get a fused ring at this position. So there will be a ring which is getting generated at this position, and after the dehydration you will get this. So this would be a fused ring. Okay. So is it clear?
Yes, ma'am.
Okay. So that is how you will get this compound. So now tell me which is the correct option.
Option 1.
Option 1. Fine. So option 1 is the
Option B.
option 1 because sorry. Huh. 1 second. Yeah, option B. No, actually, if you look at it now, you will find that option 1 is the correct answer. Why? Because look at the position of methyl. Option B doesn't contain any of the methyl group, right? And also,
Yes.
yeah, that is why option A is the correct one. So is it clear to all of you, the mechanism of this question? Okay, so if it is clear, then I'm moving forward to problem number 5. So in problem number 5, you have to identify the major product formed in the following transformation. So there is 2 steps in this particular transformation. You have to identify the product. So first of all, they have given you a alpha beta unsaturated ketone and they have treated it with methyl magnesium chloride in presence of copper chloride. So this is basically a Grignard reagent, methyl magnesium chloride. So it will behave as a nucleophile. I have told you, whenever you have a metal inserted between this alkyl halides, then there is a partial negative charge which is getting generated on the methyl group and the partial positive charge which is generated at this electropositive metal. So just like Refermatsky enolate, which I have talked about the zinc insertion between the alkyl halide bond. So zinc is getting the positive charge, the rest alkyl group is getting the negative charge, behaving as a nucleophile. Similar concept is there. So here also in the Grignard reagent, basically the alkyl group is the nucleophilic part, magnesium chloride, magnesium basically is the positive part. So it will behave as a nucleophile. So while behaving as a nucleophile, now again it has two things to attack on this particular alpha beta unsaturated compound. Either it can be done by 1,2 addition or 1,4 addition fashion. So which is preferable here? Which is to be operative here? What do you think?
1 4.
1
1 4 addition.
1,4 addition. But we have talked about that Grignard reagents are going to give you the 1,2 additions because magnesium is not a soft soft metal, it is a hard metal. So here what happens, first of all, in the presence of copper chloride there is a metal exchange which is going to be takes place. So here there is a metal exchange between magnesium and copper, and now insertion of copper between this methyl iodide will give you a soft nucleophile. So a hard nucleophile is now converted to the soft nucleophile in the presence of copper in the reaction mixture. So basically, due to the interchange, a metal exchange which is taking place, now your nucleophile is modifying from hard nucleophile to soft nucleophile, because if the copper chloride is not present in the system, then Grignard reagent are famous to give you the 1,2 addition products rather than 1,4 addition products because of the presence of magnesium, that is a hard electrophile. So here presence of copper chloride will make it a soft nucleophile. So that is why the soft nucleophile, as I have told earlier, will attack to the soft electrophilic center. So here it is going to give you the methyl addition at 1,4 position. So if your methyl is getting attached at this position, let's say, then you will have this conjugation here and again here, right? So now what will happen? Sorry. So now what will happen? Here also you will get the oxyanion generation, and after the generation of oxyanion at this position, now this negative charge after conjugation, sorry, will come down, and a double bond which is now migrated at this position after the attack of methyl, it will transfer to this position, making it as a nucleophilic position. So in the second step they have added allyl chloride, sorry. So in the next step they have added the allyl chloride. So now your negative charge after coming down will attack to this carbon of allyl chloride and chlorine will leave out. So this is how you will get two additions in a molecule. So in the options, as you can see here, they have mentioned you the stereochemistry as well. So mentioning the product as well as the stereochemistry is important in this question. So can anyone tell me which stereochemistry is operative here? Which is the correct stereochemistry in the question? Which is the correct option?
Option D.
Fourth option. So how it is going to be done? Let's talk about it. So basically, I have told you there is a transmetallation that is happening, a metal exchange from the copper chloride like this. So basically, methyl copper is getting generated, which is to be attacked by this, which is attacked on this alpha beta unsaturated ketone, giving you a oxyanion, and then in the same pot they have hydrolyzed it basically. But in our question, they have treated it with another electrophile. So this nucleophile which is getting generated will trap the electrophile which is present in the question, right? If you quench it here, it will remain ketone, but if you add another electrophile, it will attach to this position. So here also the methyl copper will attack on this position, and this will leave out the chlorine to give you this compound. But now coming to the stereochemistry. So if first of all I have attached this methyl, if I am taking it as upside, I am just thinking that it is the upside attack which is happening. So it will go down the phenyl ring. So next attack is has have to take place. So what do you think? The next attack, the another alkyl group, let's consider it as R. So what do you think? This R will come from above the plane or below the plane?
Above the plane.
Above the plane. Any other answer than above the plane? Okay,
Below the plane.
below the plane. See what is happening here. You are thinking about the sterics with the phenyl group if it comes below the plane, right? But what happen in these kind of situation that there is an anti-attack which is taking place. So there is an anti-stereochemistry which is preferable at these kind of questions. What happened? First of all, your methyl is attacking. So if your methyl is above the plane, then the again the R which has to be come which has to come will attack will will go to that position which is opposite to this methyl that is below the plane, because here there is a well-known chemistry that one attack, if it is above the plane, then the next attack has to happen as below the plane only, irrespective of the steric control. So I am thinking that you are answering according to the phenyl ring presence, but it is logical. But here in these kind of situations, the attack is anti. So first of all, one group has to attach on this particular ring. Then the stereochemistry of that group and the incoming group should be anti to each other, not the same to each other. Okay, so attack is anti. So that is why if the next group has to be present in the system, then it would be below the plane, it would be above the plane, and again this phenyl will go below the plane, right? So this is how it is. So now we will match in the particular thing. So which is the correct option? So what is happening in the question? So methyl has attacked, yes. Now this has to be attacked. Okay, I think I should go through this particular problem first, because this should be anti to each other according to the concept, but it is getting same, the methyl and this particular one. Okay, I think there should be a mistake in this particular question. So I will get back to you with this problem again in the next session. Okay. So I think there is a problem with this. Okay. So guys, I'm moving forward. I will explain this thing to in the next class, because I'm not sure whether whether this particular thing is wrong or what we are assuming is wrong. Okay. So I think there is some mistake in this particular thing. Okay. So going to problem number 6. So in problem number 6, it is very straightforward question, because we have seen this kind of problem previously also. So in this question, you have to answer which of the following is the product of the given reaction sequence. So they have treated this particular alpha beta, sorry, not alpha beta, this is the diketone here, and you have treated it with H ion heat. That is, in the presence of acid and heat, you have treated this molecule. So what could happen in this system? So in the presence of acid, now one of the these carbonyl compounds is to be protonated. So which is to be protonated now? Here I have told you a concept that more the electrophilicity. Here, if the electrophilicity is high, then this H ion, that is acidic. So if you have this, then it will form you this kind of system or this. So there is a double bond character which is arising if protonation is happening on this oxygen, right? Either way, here also there could be a double bond generation at this position. So your electrophilicity is depends. So basically in the ketone, the electrophilicity of this ketone and aldehyde, which is more electrophilic carbon, the ketone or the aldehydic one?
aldehyde.
Aldehyde. So aldehyde is more electrophilic than ketone. So so here this carbon, which is the more electrophilic carbon than this particular ketone, so now what will happen? It is getting protonated. So this carbon is getting protonated because now this double bond is getting generated and the electrophilicity of this carbon will go down. So based on the electrophilicity of these two, because you have to think about two only, because these two are symmetrical in nature, these two carbonyl groups. So you have to think about aldehyde and ketone only. So in between aldehyde and ketone, the aldehyde is more electrophilic carbon, that is than the ketone. That is why protonation will takes place at this position, will give you a double bond at this position with OH and a single bond, right? So this enol is getting generated at this position. So now next what will happen? Can anyone tell me now what will happen again next?
Nucleophilic attack
Yeah, nucleophilic attack.
carbon.
So as we have seen in the previous case of Robinson annulation, so there is the attack that was happening. So this oxygen lone pair will come down and this negative charge will attack on this carbonyl group, giving you how many ring formation? How many number of ring? I mean, how many number of?
Half membered.
So here, 5 or 6. So 1, 2, 3, 4, 5, and 6. So 6-membered ring is going to form in this particular situation to give you this. So after the formation of the 6-membered ring,
Six membered. Yes,
yeah,
six membered.
6-membered ring. So after the formation of 6-membered ring, there is a dehydration step which is going to takes place, and you will get a alpha beta unsaturated ketone. And I have told you previously, the dehydration will be facile from that position where the generation of alpha beta unsaturation is there. So that is a driving force of dehydration. Okay. So that is why here this hydrogen is getting eliminated, not this. Okay. So tell me which is the correct option now. Option number 1. So option number 1 will be the correct one. Okay. So is it clear, guys? This question.
Yes, ma'am.
So coming to problem number 7. This is also a similar kind of question. So in which you have to identify which of A to D is the intermediate compound A. So you have to identify which is the intermediate A among these 4 options, which is A. So here also they have treated this diketone and alpha beta unsaturated ketone with sodium hydroxide, water. Sodium hydroxide is a base, so it will abstract a acidic proton. So similarly, it will abstract acidic proton from this side. Attack will be 1,4 in nature, right? 1,4 in nature. and then again the oxygen ion will form an attack of the oxygen attack of the carbon ion which is getting generated to the one of the carbonyl compound. So now tell me what is the correct option, because we have done these these questions recently in two of the problem. So this is a third problem of similar line. So can anyone tell me which is the correct option?
Option B.
Option B. Any other answer than option B? So everyone agrees with option B. Okay, so option B. Why option B? Here also you will get a six-member ring generation and then dehydration step. So once you write it, you will get to know that option B is the correct one, and the dehydration is going to take place to get you the alpha beta unsaturated ketone. So option B is the correct one. So is it clear to all of you? So assuming that it is clear to all of you, going to problem number 8. So in problem number 8, they are asking you which of the following reaction does not indicate the correct main products. So among these four, you have to identify which is the wrong reaction basically. So one by one we will be identifying these reactions. So here in the first part, this ketone is treated with secondary amine with catalytic acid, and it is giving you a enamine. So is it a correct product or not? Is it a correct reaction? What do you think? Anyone? So here what is happening, guys? We have
No, not correct.
not correct.
Not correct.
Okay. So we have gone through one situation, like actually we have talked about enamines, right? So what will happen in this case? Catalytic H ion means basically acid. So here this amine will attack to your carbonyl compound, which is protonated by acid, making the center more electrophilic. So making the center more electrophilic, this amine will attack on this position, and this will go here to give you a what? You will get this O. Sorry. So you will get an OH formation here. Sorry. OH, and here you will get this amine. Not writing the whole thing. So this is amine, and this is methyl, and this is phenyl, right? Okay. So now this is having a positive charge, right? Because the lone pair has attacked. So nitrogen is getting a positive charge here. So this positive charge is neutralized by the H removal, the hydrogen removal. So basically it is having a proton, na? So it will be donating to this nitrogen, and it will get neutral. So it will get neutral. So after the formation of this particular thing, that is this OH and NME2, right? This is NME2 which is present in the system. Fine. And this is pH. And this is methyl. So this methyl and this hydroxy, basically you have hydrogens which is present here. Agreed? Because this is a methyl group. So you are surely having hydrogens. So there is a dehydration step which is going to take place. What will happen? This H will go here, and this hydroxyl will leave out. So now tell me, is it this compound or not after the dehydration?
Yes.
So this is the correct option, right? So this is the correct reaction. Now coming to part B. So this enamine which they have generated in the first step, they have treated it with this benzyl bromide in THF, and they have hydrolyzed it. So now tell me, is this the correct option? Is this the correct reaction, the main product? Just think about it and tell me. So now in this, what is happening, guys? Basically, your lone pair. We have talked about enamines. We have talked about how it will behave, it will react, or it will alkylate the another things. So here also, this lone pair of nitrogen will come down like oxygen, and this alkene, this negative charge, will attack to your carbon, leaving out Br. So this side chain is what? Attached to your carbon, and in the second step they have hydrolyzed it. So after hydrolysis, this NMe2 will go and convert it into the ketone. How? Because now you have this, after the attack you have this particular double bond which is present on the system. So you have this double bond, a positive charge here, right? So hydrolysis means the water attack. So basically water will attack here, and you have the OH formation, which will attack. After the attack, it will get neutralized. So that means you will have this OH, and this positive charge is gone. So after again this O lone pair will come down, and this NMe2 will knock out to give you what? This ketone. So there is a particular how it is getting removed. This NMe2, there is a deprotection step which is happening in the hydrolysis to give you ketone. So basically, enamines will behave as a nucleophile, and it will attack to electrophile. And after that, in the presence of hydrolysis condition, this enamines will get deprotect to get ketones. Okay, so this is also the correct option. Now coming to option number 3. So just go through this reaction and tell me, is it the correct reaction? Is the final product correct or not? Okay, let me see how I can help you with this. So here, first of all, what will happen? This triethylamine and silyl chloride. So basically, silicon will form a bond with this particular oxygen. So how it is going to form the bond? So this hydrogen is going here. It will attack onto your silicon, leaving this SiCl bond. Cl will knock out, and you will form a bond with this OSI-Me3. So now tell me the alkene, the position of the alkene in this case, and the product. Is it matching? The product which you will get here is
Butters,
sorry.
like birds in the
Yes, ma'am.
nest.
So here we get this OSI-Me3, right? And here there would be a alkene, right? So from here I'm getting this. So is it matching your right hand side? Is matching your left hand side?
No.
No. So this is not the correct product which is going to be formed in this reaction. So this is the product which is going to be formed rather than this. So now coming to option number 4. So here they have treated this OSI bond with this electrophile in Lewis acid condition. So here also what will happen? Guys, OSI bond will cleave, and here again you will find an attack on this electrophilic species. Cl will knock out, giving you this system, and this will knock out, leaving this trimethyl chloride, because Cl, which is going to be knocked out from here, will attack onto this position. So here this oxygen is getting protonated in the presence of Lewis acid. So after the protonation, this the silicon OSI bond will cleave, it will go down, and this C double bond C, which is now a negative charge, will attack onto this electrophile to give you this ketone and deprotect this trimethyl chloride. So this is the correct reaction product. This is the right reaction, but the option number 3, the product which is given here doesn't match with the reaction. So that is why the product is this, not this on this particular reaction sequence. That is why we can say that yes, this reaction doesn't indicate the correct main product. So is it clear why the option number C is the correct one? Is it clear all of you? Anyone has any doubt? Am I audible?
Yes, ma'am, it is clear.
Okay. Now coming to problem number 9. So in problem number 9, you have to identify the sequence to synthesize the cyclohex 2-enone, which is a combination of reagent is feasible for carrying out step 1 and 2. So you have to identify the combination of reagent which is carrying out your step 1 and step 2 to synthesize the cyclohex 2-enone. So here in these particular reagents, you have to put them into the situation and you have to find out which is the correct one. So in the first case, there is a alpha bromination which is happening here. So can anyone tell me which is the correct for the first step? Which is the correct suitable reagent for the first step? As it is a alpha bromination, so which condition will give you this alpha bromoketone? What do you think? Okay, so 1 by
Option
1 option A. Okay. Yeah. See, option A, in this also you can get this product, yes, because sodium hydroxide will abstract the proton from this side, and then this negative charge will attack onto your bromine, right? Good enough, fair enough. But this sodium hydroxide, as it is a very strong base, it can also it can also do the 1-2 addition and will give you multiple products. So this is not the very good condition to do the alpha bromination. So the bromination in these kind of compounds will be favorable in the acidic condition rather than the basic condition, because of the generation of multiple side products along with your product. So that is why a strong condition, that is a strong basic condition, is not employed in these kind of system. So here, if you treat this compound with bromine NaOH water, then you will find that NaOH is doing very much side reactions. So that is why it is employed in the side reactions. So that is why it is not a suitable condition for this particular transformation. But if you see in option number D, bromine acetic acid, as acetic acid being a acid, it would protonate your oxygen first, So here, what will happen? So now your this alpha hydrogen will become the acidic one. Is it already? It is actually already acidic, but now it will form this hydrogen much more acidic because of the protonation of this carbonyl group. So that is why this H will go here and this will go there. So now what will happen? So what will happen? Here you will have a double bond which is present in this position and a single bond at this. Right? So now in the presence of bromine, this oxygen, this charge is getting neutralized after the double bond formation. So now the lone pair of this oxygen will again come down and this CC bond will react to your bromine. One bromine will lock out to give you what? This compound. So that is why in the presence of bromine in acidic condition, there is very much less chances of forming a side product because it is a mild condition. But when you use a strong base, that is sodium hydroxide, then as it is a nucleophilic base, so it can also act as nucleophile and it can give you multiple products. So that is why this condition is suitable for the alpha bromination of of the cyclohexanone rather than the basic condition. So is this much understood to all of you?
Yes, ma'am.
Okay. Now coming to step 2. So in step 2, what is happening? There is a HBr elimination which is happening here. So can anyone tell me which condition is suitable for this particular thing?
Basic condition.
Yeah, basic condition. So here also again the similar concept arises, and you don't want to use a strong base because of the side product formation. So here if you use a very strong base, then it will attack onto your carbonyl group and it will give you multiple products. So here triethylamine and sodium ethoxides. So which is a weaker base, triethylamine or sodium ethoxide?
Right element.
Triethylamine. So being a weaker base, triethylamine can do this job rather than the sodium ethoxide. Because if the sodium ethoxide is employed, I have told you it will form you as multiple side products. So here option number D will be the correct one. Bromine acetic acid is suitable for first step and triethylamine ethanol is suitable for the second step. So is it understood all of you? Anyone has any query in this question? So if not, then I'm moving to problem number 10. So guys, problem number 10 is very simple. So in which you have to answer what are the different steps of a Robinson annulation. 1,2 addition, intramolecular aldol condensation, enolization, aldol dehydration, Michael intermolecular aldol condensation, Michael intramolecular aldol condensation, and then aldol dehydration. So can anyone quickly tell me? We have seen so many examples of this Robinson annulation previously. So just tell me which is the step which is involved in this particular Robinson annulation. Any
Last option.
last. So if anyone has any doubt, just let me clear the air. So here in the Robinson annulation, previously also we have seen that first of all what is happening? Base will abstract a acidic proton as it is happening in this question. This is also a Robinson annulation product. So here the base is abstracting the proton and after that nucleophilic attack is taking place. So basically this nucleophilic attack is a 1,4 addition which is happening. So it is known as Michael addition. So we have talked about that Michael addition is 1,4 addition to the alpha beta unsaturated ketone. So here 1,4 addition is happening. That is why we are saying that Michael addition is taking place. After that, the second step is this oxyanion which is getting generated will do it the aldol condensation with this carbonyl compound which is present intramolecularly in the system. So intramolecularly, it will do the aldol condensation at this step. So you can see here, this is a carbon ion generation, and then this carbon ion will attack to the carbonyl group to give you the intramolecular aldol product. So after the intramolecular aldol condensation, the next step is the dehydration. So basically, we dehydrate it to form the alpha beta unsaturated ketone. So now coming back to the question is asking either the 1-2 addition takes place. So this is not the right answer because we know that 1-4 addition is going to take place, not 1-2. Enolization and aldol dehydration, it is also not there. Enolization is not the first step. So here in the third option, Michael addition, right? Intermolecular aldol condensation. And I have told you for the Robinson annihilation, we have seen that intramolecular aldol condensation is happening. So intramolecular condensation is happening in this question, and after that aldol dehydration. So these three are the step which is matching with your Robinson annihilation. That is Michael addition, intramolecular aldol condensation, and then dehydration. So that is why option number 4 is the correct one. So is it clear, guys? This question. So if it is clear, I am moving forward. Problem number 11. So now again you have to find out the wrong main product. So in the one by one we will go through it. So in part A, alpha beta unsaturated aldehyde, Grignard reagent diethyl ether, and present, and the second step is hydrolysis. Can anyone tell me, is it the correct product? Tell me, guys. So here what is happening? This is the nucleophile, right? I have told you that Grignard reagent is the alkyl part is nucleophilic in nature. So this will be the nucleophile. So now it has to be attacked to alpha beta unsaturated ketone. So it will attack in 1-4 fashion or 1-2 fashion.
1-4.
1-4. I have told you that Grignard reagent, the magnesium being the hard metal, it is not going to give you the 1-4 addition. It is going to give you 1-2 addition only. Why 1-2 addition? Because see, you are confusing with this particular question. Yes. So here in this Grignard reagent, you have added copper chloride to make this kind of species, that is the transmetallation is happening, and after that this is becoming the soft nucleophile to give you 1-4 addition product. But in this case, what is happening? There is only the Grignard reagent, so it is going to give you the 1-2 addition rather than the 1-4 because of the hard metal and hard electrophilic center. So it will attack to this position rather than 1-4 position. So now tell me, is the reaction main product correct or not? Anyone? See, I have told you that it is a 1-2 addition product. That means ethyl is going to be at this position, right? This would be OH, and this alpha beta unsaturation is untouched. So is it matching with this product? It is not matching with this product. So that is what
No.
this part is incorrect one. So now we have to see all of these. So in the part B, there is the allyl nitrate in which you have added the secondary amine in ethanol. So what it will do? Secondary amine, it is a nucleophile. This is the double bond. It is going to attack on this position. So is the attack 1-2 attack or 1-4 attack? So here also this amine is attacking into 1,4 fashion. How 1,4? Guys, if you expand this nitrate, you will get to know that this is the double bond oxygen. This is oxygen with a negative charge. So this is the alpha beta unsaturation which is getting into the molecule. That is why here also 1,4 attack is possible, because triamine will attack onto this beta position to give you this compound. So this is the right answer. This is the right correct main product. So again in the part C, you have to attack this enamine to this alpha beta, so this acrylonitrile in presence of ethanol, and in the second option they are doing the hydrolysis. So tell me, is it the correct option? Is it the correct main product which is written in the reaction?
Yes, that is correct.
It is correct. How it is correct? This lone pair will come down, as we have talked about enamine. It will attack to this position, then it will go here, abstract a proton from the ethanol to give you this, and this enamine, this imine will hydrolyze to give you ketone. Now part D. Is it correct, guys? Part D, the main product.
This is also correct. Correct.
Yeah, so this is the basically correct option. Previously we have seen it, so this is the correct option. So now coming to problem number 12. So this is the very quick question. So in this you have to answer what will be the X in the below mentioned sequence. So you have to find out the X. So you have started with aniline. You have treated it with sodium nitrite in concentrated HCl. So here you will form a what? What you will form? What will be the product? Diazonium salt. So here diazonium salt is getting formed
Yes.
first. Okay, the you are answering it. Okay. So first the diazonium salt is getting formed, and again they have treated with sodium nitrite. So sodium is positive here, nitrite is negative. So if you have diazonium salt, that is N2Cl, and you know that it is electrophilic in nature, right? You have this positive charge here. So now this nitrate will attack onto your ring. This is how it is. This is N2. So this nitrate will attack onto your ring, leaving out this N2 and give you nitrate. In the presence of tin HCl, what will happen? There is a reduction of this nitro which is taking place in presence of tin and HCl to give you again aniline. So that is how you have got aniline to aniline conversion. So first of all, diazonium salt is getting formed in the presence of sodium nitrite. Then the nitro will attack onto this position at this carbon, leaving out nitrogen as a neutral molecule. And after the formation of nitro, there is another step, that is the tin HCl reduction to give you X. So that is how you will get the aniline from the nitro reduction. So which is the correct option now here? Option number
Option B.
B. So that is why A is not the correct one. Again, the nitro is getting reduced to amine by tin HCl. Okay, is it clear to everyone? Okay, so moving forward, if it is clear. In problem number 13, what will be the product of the following reaction? So they have treated this nitroalkane with ketone or aldehyde in the presence of base and solvent. So basically base is there, nitroalkane is there, and it is attacking onto this ketone and aldehyde. So can anyone tell me what will be the reaction product? It is a very simple reaction. So one by one we will see it. It is a base. What did base do? So base will abstract a proton. So which proton is abstractable here?
adjacent to
Adjacent to
nitrate group.
nitro, yeah. Adjacent to nitro. So this is the acidic proton because of the nitro. This hydrogen, nitro is a electron withdrawing group. That is why making this hydrogens acidic in nature. So carbon ion which is getting generated here is highly stabilized by nitro group because of the resonance as well as electron withdrawing group. So after the generation of this negative charge, now it will attack to your ketone or aldehyde carbonyl group to give you this compound. So now name it. The compound which is forming here, can anyone name it and tell me which is the correct option? So what you will get? Making things easy for you.
Alpha nitro alcohol.
Alpha nitro alcohol. Okay. So this is OH. In the same carbon you have CH2, right? And you have NO2, and this position you have R. No, not this position. This position you have R. This is again R. This is again R. Now name it. What is it? Alpha?
Beta nitro.
Yeah, beta nitro. How beta? This is alpha carbon. This is beta carbon. Right? So this is either way you can write it alpha or beta. This is beta nitro alcohol. So this is how it is. So this is alpha carbon. This is beta carbon. So it is beta nitro alcohol, not the alpha nitro alcohol. Okay. So the correct option is beta nitro alcohol. So is it clear, guys? If it is clear, then I'm moving forward to problem number 14. So you have to identify the major organic product formed for the following reaction. So basically this is the alkene. In first case you are doing the ozone treatment and second zinc hydrolysis. So can anyone tell me what will be the product of this reaction?
Dihalo.
Di. Sorry, can you repeat?
Option D.
Option D. Dialcohol. Guys, it is the ozonolysis reaction. Right? You are treating it with O3, that is ozone. So what will happen? O3 will add to your alkene. Here you have alkene. O3 will add to give you molozonide, which again rearrange to give you these recombined fragments, which give you the ozonide. And after the formation of ozonide at this carbon, after the reduction, you will get the ketone molecule. So basically, there is a CC bond cleavage, and what you will end up with? Two carbonyl compounds. So now tell me what will be the correct option? I have I have seen you the basically mechanism. I've told you this. This is the ozonolysis reaction, reductive ozonolysis. So now what do you think will be the correct option based on this mechanism? So first of all, alkene will react with ozone, form molozonide, which will recombine to basically cleave your CC bond. And after the cleavage of your CC bond, these fragments again recombine to give you the reduction product, that is the ketone. So now tell me what will happen here.
Option A.
Option A. This option is the correct one. How? This CC bond is getting cleaved, and because this is a reductive ozonolysis, you will get the formation of aldehyde because here there are presence of hydrogen. This is the secondary carbon center, na? So that is why you are getting generated of this. You are getting aldehyde generated rather than the ketone. So option number A is the correct one. So any doubts, any queries in this question? Is it clear? Okay, so if it is clear, then please ask me if it is not clear. Okay. So I'm just assuming that it is clear and I'm moving forward. So in problem number 15, they are asking you what is the major organic product formed from the following reaction. So they have a alkyne and they have hydrolyzed it in presence of HgSO4. Anyone has any guesses what this alkyne will form after hydrolysis? Let me let me give you a hint. So here what will happen in this reaction mechanism? If you have alkyne in the system, the mercury will bind to it and forms a cyclopropane kind of ring. It will add up to it, and then the water, that is hydronium ion here, basically this water will attack onto your one of the carbon atom and break this cyclopropane ring. So here the attack will takes place at more substituted center. So more substituted center attack will takes place, and after that this mercury which is getting generated here will go the ketonol tautomerism. So there is a ketonol tautomerism. I have told you that if you have enol form, you can convert it to corresponding keto form, but keto form is more stable than enol form. So keto form is getting formed, and there is a loss of mercuric ion to form this particular species. How it is going to form? This is going here, and you will get the abstraction of this H from the water molecule. After again the ketonol tautomerism, you will get this aldehyde or ketone based on the alkyne substituents. So this is how the addition of this hydrolysis is taking place of the alkyne. So first of all, what is happening? This mercury will bind to your alkyne to form the cyclopropene ring, and this water which is present attacks on the more substituted side to cleave that particular cyclopropene ring. Again, there is a ketonol tautomerism which is happening. So here you can simply also show that this mercury is getting leaved out, and after the ketonol tautomerism will generate a more substituted ketone. So in this reaction, if you replace your R and H correctly, you will get what the final product is. So based on this mechanism, can anyone tell me which is the correct option?
Option D.
Option B.
Option B.
Option
D.
B or D?
B for Bombay.
So option B will be the correct one. Why? Because here I have told you that it will attack to more substituted site, the water molecule, and here the more substituted site is attacked by the water molecule, and you will get this ketone molecule rather than the aldehyde, right? And also the carbon chain is longer. So B is the correct option. Now coming to problem number 16, which is the last question of today's session. So it is a very simple question. So in this question you have to answer what is the major organic product obtained from the following reaction. So they have treated acetone with Wittig salt. So this is the Wittig reaction. This is a name reaction, that is the Wittig reaction. So basically this is the salt. This is a Zuten ionic form. So it will react with your ketone to give you a product, and you have to identify that product. So can anyone tell me quickly what would be the product? So guys, I have given you the hint that it is a Wittig reaction. So what do you mean by Wittig reaction? So let me tell you the mechanism of this and then you will surely answer it. So here what will happen, the Wittig salt which is here, which is present in ketonic form. So here what is happening, in the presence of ketone, this CH2 minus will attack to the carbonyl carbon, which is electrophilic in nature, and then this oxyanion will is going to form a oxaphosphatane ring after attacking counterly to this phosphine. So this phosphorus, being the positively charged, will be attacked by the oxyanion to give you the oxaphosphatane ring, which is this. Basically, this is a betaine ring which is forming, and after the formation of this, it will collapse, the cyclobutane ring will collapse to give you alkene and triphenyl phosphine oxide. So this is the volatile. So this is the triphenyl phosphine oxide which is getting formed as a byproduct, and the main product is the alkene formation. So based on this stepwise mechanism, can you tell me what will be the product of this reaction?
Methyl propane.
Yes, option number A, 2-methyl propene. So this is the similar example only. So here you can name it. So this is acetone which is reacted with this particular Wittig salt. So this is the same question. So here you can number it 1, 2 and 3. Then you will realize after IUPAC name that it is a 2-methyl propene. Right? So the option number 1 will be the correct option. So is it clear guys, this question?
Yes, ma'am.
Okay. So if it is clear, then I'm just stopping the session here because this is it for today. So if you have any queries, any doubts regarding any of the question which is discussed today, please tell me now. And if you don't have any doubt, then I'm just closing this session now. And you will find the video of this lecture on my YouTube channel. So thank you so much for joining, guys. So I'm stopping.
Thank you, ma'am.
Thank you.
Thank you, ma'am.